to help us review how to multiply mixed numbers. Okay. So if I have the problem 2 1/4 times 1 3/8, how are we going to go about solving this problem? There are two different ways or two different strategies we've discussed on how to go about solving this problem. The first strategy is to use a generic rectangle and to use what we know about the area model to multiply each part together and then add up all of the parts at the end to find our final product. The second strategy we've discussed is converting each mixed number to a fraction bigger than 1. This will allow us to multiply straight across as regular fraction multiplication and then involves some simplifying or reducing at the end. We're going to discuss both strategies throughout this video, starting with the generic rectangle. So, first, we're going to draw the generic rectangle. Remember to give yourself enough space so you have room to work. I'm going to label my generic rectangle, my first fraction, or mixed number. I have 2 1/4, 1 3/8. I'm breaking apart each mixed number by place value and labeling each section appropriately. Because this is called the area model or generic rectangle, I'm going to multiply to find the area of each section of my generic rectangle. So starting with the upper left corner, 1 times 2 will give us 2. I see the next moving to the right is 1 times 1/4. Remember to write a whole number as a fraction. They automatically have a denominator of 1, so I can multiply straight across. 1 times 1 gives me 1 over a denominator of 4. 1 times 4 giving that 4. Right, moving to the bottom left, 3/8 times 2, again over 1 because it is a whole number. 3 times 2 gives me 6. 8 times 1 gives me 8. And we're left with 3/8 times 1/4 to get 3 over 32. So right now we have these 4 parts that we've multiplied, and we now need to add up those guts, add up the insides to find our final product. So I'm going to rewrite what we're adding down below. We have 2 plus 1/4 plus 6/8 plus 3 over 32. As I'm looking at these, I realize we can't add them yet because we need common denominators. Anytime we are adding or subtracting fractions, you must find common denominators. So right now we have a 4, 8, and 32. I notice that 4 and 8 both multiply together to make 32. So I'm going to find a common denominator for all my fractions of 32. Okay, which means this one I can leave by itself because it's a whole number. I can worry about that at the end. And this one already has a denominator of 32, so I can leave that one alone for right now. So really, I'm finding common denominators between these two fractions. They still need the common denominator of 32 to be able to find our final product. So let's use our knowledge of giant ones to do that. I have 1/4 times some giant 1 to get to a denominator of 32. And we have 6/8 times some giant 1 to get to a denominator of 32 as well. So 4 times what gets me to 32? Well, 4 times 8 gets me to 32. So for this to be a giant 1, the numerator also has to be 8. Remember, we need to change our numerator as well as our denominator. 1 times 8 will give me 8. So my 1/4, the equivalent fraction we found, becomes 8 out of 32, having that common denominator of 32. Moving over to 6/8. 8 times what gets us to 32? Well, I know that is 4. 8 times 4 is 32. For my giant 1 to be equivalent to 1, that has to be a 4 over 4. 6 times 4 gets me to 24. So the equivalent fraction we found for 6/8 becomes 24 over 32. So now again, we can see 1/4 now became 8 over 32. 6/8 now became 24 over 32. So that kind of looks confusing. Let's rewrite our sum or our guts with the equivalent fractions. We have 2, all the numbers up here I'm rewriting. So we have 2 plus, not 1/4 anymore, now it's 8 over 32 plus not 6/8 anymore, now it is 24 over 32 plus the 3 over 32. So now I see I have common denominators. I can add my numerators. So I'm going to keep, don't forget this whole number out front. That's very important. We have 2 plus something over 32. So 8 plus 24 is 32 plus 3 more will get us to 35. Okay, I'm still not done yet. I still have to add in that whole number. And notice that this number right here, when we're done combining all of those fractions, is now a fraction greater than 1. So we have some simplifying to do. So 35 out of 32. I know 32 can go into 35 one time. So if I take 32 away from 35, that'll leave me with 3 left over. 3 out of 32 left over. When I finish adding, I know 2 and 1 make 3, with that 3 out of 32 left over. My final product being 3 out of 32. Now, notice we do not just multiply 2 and 1 to get 2, 1/4 and 3/8 to get 3 out of 32. No, we have to go through and multiply each part, okay? We can't forget about multiplying the whole number and the fraction of the other opposite numbers together. We have to multiply all parts together. It does not work like addition. You have to go, you cannot just do the whole numbers and the fractions. And a generic rectangle really helps us see that we're multiplying all of those parts together. Okay, so our final product does in fact become, if I can get there, oh no. Our final product really does become the 3 and 3 out of 32. There is another way to multiply these mixed numbers. Our second strategy is to convert to fractions bigger than 1. So how do we go about doing that? Well, to convert 2 and 1/4 to a fraction bigger than 1, we multiply the denominator and the whole number together. And then we add in the numerator. So this becomes 4 times 2, which equals 8, plus 1 more gives us 9. Then we bring in that denominator, so this becomes 9 over 4. I can do the same thing with 1 and 3/8. I multiply the denominator with the whole number out in front. That gives us 8 times 1 to get 8, and I add in the numerator. 8 plus 3 gives us 11. I bring in that original denominator, so this becomes 11 over 8. I've converted them both to fractions bigger than 1. I can tell they are fractions bigger than 1 because our denominator is smaller than our numerator. But now, since we have two fractions, I can multiply straight across, like regular fraction multiplication. So I can multiply my numerators and my denominators. 9 times 11 gives me 99 over 4 times 8, which gives me 32. I could leave my answer like this, or we could simplify further, change it back into a mixed number. This is still a fraction bigger than 1, so I'm going to see how many times my denominator goes into my numerator. How many times does 32 go into 99? 32 goes into 99 3 whole times and leaves 3 left over. 32 times 3 gives us 96. Again, you can use a calculator for this. That is okay, you're showing your work here. Gives us 96. Well, 3 more make 96. So I have 3 left over out of 32. Notice that this is the same answer that we got before, earlier, using the other strategy as well. Either strategy, using the generic rectangle or converting to fractions bigger than 1, both give you the same answer. Both strategies work. It's whichever one you prefer. As long as you are remembering to multiply all parts of numbers together. So again, using that area model, we're multiplying the whole numbers, the fractions, and the whole number with the opposite fraction and vice versa. If you are still confused, if you would like more practice, or you still have questions, please see Ms. Zabrowski or Ms. Weiss for further clarification and further help. We are here during homeroom, before school, or during lunch to answer any and all questions that you have. So please, please, please come in and get help whenever you feel you need it. We are here to help you. Hope this video helped. Have a good day.